Welcome to the first unit of our course, Using Get and Map Functions. This unit marks the beginning of your journey through the second course in the Make Intermediate learning path. Here we're focusing on how to efficiently retrieve values from arrays and collections using the Get function. Before diving into content, it's important to have a solid understanding of arrays and collections. If you need a refresher, we've covered these foundational topics in our introductory course on data, types, and structures. Get ready for an engaging and interactive experience where you'll deepen your understanding and enhance your skills. Let's get started. As we dive into this course, it's important to revisit the concept of functions. Functions are essential tools in transforming data, making it more manageable and easier for us to work with. In this context, think of functions as the bridge that converts raw data into a more usable form. Consider situations where you need to change data from one format to another. For example, if you have a numerical date value and you want it to read as a human readable text, functions can handle this smoothly. They ensure that the data is appropriately formatted, facilitating further processing. Now, let's focus on what best describes the functions in Make. Think about their role in transforming data to enhance readability and processing. This understanding is crucial as you progress in learning how to use the Get and Map functions effectively. In Make, functions are essential tools that help transform data into a format that's easier to read and process. Think of them as translators that reshape data, ensuring it's in the correct form for your needs. For instance, you might want to change a date from a technical format like 20230618000000.000z, to something more readable such as June 18th, 2023. This process not only enhances clarity but also ensures that all data elements align properly, making your tasks more efficient and accurate. Functions enable you to work with data seamlessly, adapting it to suit your specific requirements. Let's dive into the intricacies of data types, focusing on arrays and collections. Imagine a shopping basket system where you've got various items, each with details like name, price, and color. Here, you see that arrays and collections work together to organize this data efficiently. A collection groups related data points together, much like organizing your groceries into categories. In our example, each item in the shopping basket is nested within collections, and the items themselves are stored in an array. This structure allows us to manage and process complex data sets by breaking them into manageable pieces. You can iterate over these collections to extract just the information you need. As you progress, you'll learn how to use the Get function to pull specific data from arrays or collections, streamlining your data management tasks. Understanding this structure is key to accessing and handling your data effectively. Let's delve into what the GetAlgorithm function is doing in this context. Imagine you have a list containing multiple items, like a shopping list. Sometimes you want to pick just one item from that list. That's where the Get function comes into play. It skillfully extracts a specific item, much like selecting the exact product you want from a shelf. In the example shown here, the Get function is targeting the fourth item within an array. Think of it as pointing towards a particular pair of boots you've been eyeing. Once it identifies the correct item, it places it into a collection, ready for further use or analysis. This function simplifies the process of sorting through data to pinpoint just what you need, saving both time and effort. As you progress, understanding how to utilize such functions will enable you to handle complex data efficiently, turning heaps of information into useful insights. Now let's dive into the Get function, a handy tool when working with various collections and data arrays. Imagine it as a personal assistant within a massive library of information. Its primary job is to fetch specific pieces of data that you request. The getU function efficiently extracts values from different kinds of data structures. Whether you're dealing with a simple list or a complex array of collections, it knows how to navigate and retrieve exactly what you need. Think of it like a shopping assistant in a huge store. You tell them what you're looking for, and they bring it to you. In the digital world of Make, this function acts like a courier, moving between systems to gather required information. So whether you're working with databases or integrated apps, Get ensures you have the right data at your fingertips. Picture yourself in a shoe store asking an employee for that perfect pair of purple boots. Similarly, the getD function fetches specific data from a sea of options, making your task easier and more efficient. Imagine you're looking at a large collection of shoe data. Each pair has its own unique details, like size and whether they're vegan friendly. Now, not every shoe will have a label telling you the material, unless they're specifically vegan friendly. Here's where the get function steps in. It helps you check each pair to see if those vegan friendly boots come with an extra note about their material. Think of it like searching through a pile of shoes, looking for that green sticker that tells you they're made from sustainable materials. But remember, the get function doesn't work magic on its own. It's when you blend it with other tools, like using an if statement, that it really begins to help you dig deeper. So while you have to go through the closet one pair at a time, mapping each shoe's details becomes much easier with this approach. This makes Get a powerful assistant in organizing complex information. Let's explore the Get function, a versatile tool used to retrieve data from objects or arrays. This function can navigate the structure of your data, accessing values using a clear pathway, often referred to as a value path. To dive into deeper layers of nested objects, you'll employ dot notation. Think of it like finding a specific book in a library section. Each dot helps you navigate the shelves of data. When working with arrays, remember that they're one indexed in this context, meaning the first element is at index 1. You'll find the get function within the mapping panel, classified under general functions. By hovering over it, you can uncover an array of explanations and practical examples illuminating its use. As depicted, the function follows a specific structure. Gaining an understanding of this format will enable you to unlock its full potential. Let's delve deeper to enhance our grasp on how this function can be leveraged effectively. To effectively use the get function, start by identifying the object or array you need to pull information from. Think of this object or array as your source, similar to how a shoe shop serves as the starting point for finding a pair of boots. In programming, this source houses all the data you might need. Imagine hovering over items to discover what type of data structure they belong to. This step helps you confirm whether you're dealing with a collection or an array, making your subsequent actions more precise. Keep in mind that these structures are key to accessing relevant data effortlessly. With a clear understanding of your source, you are well on your way to retrieving the specific information you need. To effectively use the get function, think of it as two main parts, the object or array and the path. The object is your source, much like a shoe store for data, but to find what you're really looking for, like that perfect pair of boots, you need to specify a path. This path acts like your directions, guiding you to the exact spot where the desired information resides within your data structure. By clearly defining this path, you can efficiently extract specific details even from the most complex data collections. It's all about pinpointing precisely what you need from a broad range of options, streamlining your data retrieval process. Dot notation is an essential concept to grasp when working with nested objects in JavaScript, the language that powers Make. Imagine you have a vast library stored within a single book. Each chapter and page is accessible through a specific path. Dot notation is your guide. It provides a straightforward way to access the precise piece of information you need within complex data structures. To use it, start with the name of your object, which acts as your starting point. You then follow it with a dot, like a period at the end of a sentence, and finally, the name of the property you're interested in. This method is not only common but also intuitive, allowing you to navigate quickly through layers of data. For example, if you're accessing a menu and want to find out more about the pizza option, you'd simply write something like food.pizza. It's akin to writing a direct address to take you straight to the desired section. This simplicity is why dot notation is a fundamental tool in your JavaScript toolkit. Dot notation is a straightforward way to access specific properties within objects in JavaScript. Imagine you are managing a store inventory which contains various items, one of which is boots. Each item has several properties such as color, brand, and size. To find out the color of the boots, you use dot notation by typing quote boots.color. This essentially tells the program to look into the boots object and fetch the value associated with color. It's like pointing directly to the information you need, making your code cleaner and easier to read. So whenever you need to access a property of an object, dot notation is your go-to tool. To effectively use dot notation in a program like Make, you need to understand the concept of raw names. Raw names are crucial when you're dealing with collections and arrays within your data structures. Think of the raw name as the original back-end name of an item. This ensures that when you refer to it, you're using its unaltered form exactly as the system recognizes it. This is especially important when working within nested objects. If you have an array, you'll also need to know the index of the item you're accessing. By using the precise raw names, you avoid any potential issues that could arise from formatting changes or transformations applied by modules. So, mastering the technique of using raw names and understanding their role in accessing specific elements will streamline your work and help maintain accuracy in data handling. When working with dot notation in Make, identifying the raw name of an item is an essential step. To do this, simply hover over the item you're interested in. A pop-up will appear, and you should look for the word raw. The text that follows is the raw name of your item. This is crucial because the raw name represents the unmodified identifier used in the system's backend. Once you know the raw name, you can easily copy and paste it into the necessary field, ensuring precise access to your data. This practice helps avoid errors and ensures seamless integration within your workflows. Dot notation is a crucial concept in programming that allows you to access specific pieces of data within an array or collection by using raw names. Raw names are essentially the key identifiers for elements. It's important to remember that they are case sensitive. This means the spelling and capitalization must match exactly. If there's even a small error, like using item underscore color instead of the correct item underscore color, your program will return nothing because it won't find a match. In some cases, the display name of an item may differ from its raw name. For instance, an item labeled as Contact ID might have a raw name of just ID. This can be a bit tricky because what you see isn't always what you use in your code. Always ensure you're using the precise raw name as it directly affects data retrieval and manipulation. Understanding these nuances helps in efficiently navigating and accessing data structures, forming the backbone of effective programming practices. Welcome to the practical phase of our learning journey. Imagine you own an online clothing store and you aim to understand your customers' purchasing behaviors better. This involves knowing the number of items they purchase, details about these items, and identifying the most expensive products on their shopping list. In this exercise, you'll create a scenario that extracts the most expensive item from a customer's order. You'll utilize the power of functions like sort and get to achieve this. We will provide you with a sample JSON dataset to work with, which represents customer orders. Keep in mind, although we're supplying this data for practice, similar data could come from various applications that the Make platform supports or can be manually crafted. Before you proceed, ensure you follow each step meticulously. Let's dive in and bring this scenario to life, shall we? Now that you've grasped the theoretical foundation, it's time to dive into the practical application. We're setting the stage for your eShop scenario, where you'll analyze customer orders using JSON data. Begin by creating a new scenario and give it a descriptive name like make intermediate to 1. Next, incorporate the JSON module to parse data. This involves copying the provided JSON code and placing it into the appropriate field. This JSON string is your blueprint detailing the order information you'll work with. Once you've pasted the JSON, make sure to save your settings. This step ensures that your data is ready for further manipulation. By carefully following each process, you lay the groundwork for a seamless integration and analysis of customer data, essential for enhancing your eShop's capabilities. Now that you've set up your scenario, let's explore the data from your JSON string. When you run the module, the output reveals a collection that details your shopping basket. This collection includes key information such as the date of the order ID, and the total price. Within this data, there's a list called items, which is structured as an array. This array contains 6 separate collections, indicating your order has 6 items. Each item in this list has specific attributes: an item name, a price, and a color. Running the module allows you to view this data directly, which can be incredibly useful for understanding the details of the order you're processing. Remember, seeing the output firsthand helps you verify that your setup is correct and gives you insight into how your scenario is unfolding. Now that you have your list of items from the shopping order, the next logical step is sorting these items by price. This process not only helps in organizing the data, but also provides insights into customer purchasing behavior and cost trends. To accomplish this, start by navigating to the Tools menu and selecting the option to set multiple variables. Once there, under the Variables section, add a new item. You'll want to name this variable Array Sorted by Price. This naming convention keeps your data organized and easily identifiable. Sorting by price will enable you to pinpoint the most and least expensive items quickly, facilitating better decision-making and inventory management. Whether you're analyzing spending patterns or preparing for a sale, understanding the cost distribution of your products is invaluable. In this part of building your scenario, you'll explore various functions designed for working with arrays. Arrays are powerful tools in programming, allowing you to store lists of values efficiently. Each function here serves a specific purpose. For instance, the join function can combine array elements into a single string, while length gives you the number of items in an array. When sorting items, you'll use the sort function. This is particularly useful when you want to organize your array by price. When you apply this function, remember it can sort data either in ascending or descending order, depending on your needs. For our use case, sorting in descending order makes the most expensive items appear first. Functions like map and filter help transform or refine your data, whereas reduce can condense an array into a single value like a sum. Using these effectively can provide deeper insights like understanding customer purchasing patterns. Understanding and utilizing these functions will greatly enhance your ability to manipulate data, making your scenarios more dynamic and insightful. As you proceed, think about how these tools fit into your overall data strategy and how they help in crafting detailed, informative analyses. Now that you've explored the theory, it's time to dive into building your scenario. Let's focus on how to sort values within an array. When sorting, you can select from several order options: ascending, descending, and even case-insensitive variations of both. This flexibility allows you to tailor the sorting process to suit your data specific needs. Additionally, understanding how to manage properties within complex objects is crucial. By using the key argument, you can directly access specific properties, making data handling more efficient. Always use raw variable names for keys to ensure accuracy. When accessing nested properties, dot notation becomes your new best friend. Remember, even though we often think of the first item in an array as index 0 in many programming contexts, here it is referred to as index 1. This distinction is essential for your success as you implement these skills. Before moving on, explore the sort function in the array functions section to see how this all works in practice. It requires a particular syntax, so take your time to familiarize yourself with it. With these foundations, you're well on your way to mastering array manipulation in your scenarios. Now that you're ready to implement the sorting function, let's walk through how to effectively organize the prices in your shopping cart. You'll start by entering the sort function into the variable value field. This function helps you order the prices from highest to lowest. First, you need to input the shopping underscore basket dot items array within the function. This array represents the collection of items you wish to sort. To sort in descending order, you'll add a semicolon followed by desk. This specifies the order you want. Next, introduce another semicolon and specify item underscore price using its raw name as the key. This is critical as it indicates that you're sorting based on the price of each item. Make sure to close the function with a parenthesis to ensure it executes properly. Once you've configured everything, click OK to finalize and save your changes. This step ensures that your modifications are updated and ready for use. By following these precise steps, you're able to manipulate data efficiently, enhancing your ability to manage complex objects in practical scenarios. Let's take a closer look at sorting your shopping basket items. We're using the sort function here, and within it, shopping basket items represents the array we want to organize. Think of this as a list of all the items you've added to your virtual cart. Now, the term desk is short for descending, which means the items will be arranged from highest to lowest price. This is handy when you want to see the most expensive items first. The key piece of information here is item underscore price. This is the specific attribute we're using to sort the items. Since this key is case sensitive, it's crucial to use the exact raw name. A helpful tip is to hover over the item to reveal its raw name, ensuring accuracy by copying and pasting it directly into your function. By following this methodical approach, you'll effectively sort your shopping basket by price. Let's continue building your scenario by examining how our function performs. Start by running the module once. This will help you verify if the output matches our goal. Having the list sorted with the pricier items on top. Once you execute the function, take a look at how the items are arranged. You should see the most expensive item leading the list, gradually descending to the least costly one. This step is crucial as it confirms that our sorting key works correctly, organizing items based on their price. Remember, this ordering is key to efficiently processing and analyzing the items for further steps in our scenario. With this sorted list, you'll be well prepared for the next actions we'll take. In this part of the scenario, we're focusing on identifying the most expensive item from our shopping list. To do this, you'll use a function called get. Begin by adding a new module titled Set Multiple Variables under the Tools section. Next, within the Variables area, click Add Item to create a new entry. You're going to give this variable a name that clearly identifies its purpose, type, most expensive item. Now let's set the value for this variable. Enter the get function. Within the parentheses of this function, you'll reference your previously sorted item array. This tells the function which list to work with. Add a semicolon after the array reference. The next part specifies what you want to extract. Type 1.itm underscore name to focus on the item at the top of the list. Since you already sorted it by price, this will be the most expensive item. Finish by closing the function with the parentheses. This setup allows the system to efficiently identify and store the name of the most costly item for further use in your scenario. In this part of our scenario, we're diving deeper into how the get function works in tandem with an array that's been sorted by price. The get function is essentially your tool for fetching data. You've already sorted your shopping list by price, and now you're pinpointing exactly what you want to retrieve. Imagine the array as a collection of boxes, each containing an item. The one represents the index or position of the target box within that collection. It's like saying, please open box number 1. Next, the term item underscore name is your focus within that box. It indicates that you're specifically interested in the name of the item inside. So not only are you identifying which box to open, but also what part of the contents you want to extract. Finally, once everything is set, don't forget to click OK to confirm these settings. This ensures your module is properly mapped, making your scenario flow seamlessly as you progress. In this part of the scenario, we're building on the foundation we laid with the sort and get functions. First, ensure that the output from the previous step is correct. It should highlight the most expensive item in the array, which is the leather boots in our example. This process involves sorting items by price and then selecting the top entry. Congratulations on successfully setting up this scenario. By combining these two functions, you've effectively manipulated data in a meaningful way. With this setup, you can now explore further applications. Imagine sending this data to other platforms, such as a messaging system or a spreadsheet, to visualize or share information with others. Think about how these operations could integrate into your broader workflow, enhancing the ways in which you handle data. Keep experimenting to see what other creative solutions you can develop. Congratulations on completing this unit. You've gained essential skills in using the get and sort functions, which are incredibly useful for organizing and retrieving data. These functions allow you to handle information more efficiently, streamlining your workflow. You've also learned about dot notation, which provides a straightforward way to access object properties, making your code cleaner and more readable. Understanding raw names helps in working directly with data attributes, giving you more control over your coding structure. In the next unit, you'll dive into the map function. This powerful tool is key to transforming data sets and will further enhance your ability to manipulate and analyze data effectively. Keep up the great work and get ready to broaden your capabilities even further.